What we are trying to do together with here is making sure that the time from change to map update is as short as possible. And we do that in a number of ways. Of course, we need to have that capacity for fresh imagery. That's by the by, and Legion enables that in ways that it was impossible before. But now it's also understanding where things are changing and anticipating that change, and maybe make our users aware there are things that are changing that they don't know about yet.
No data set is perfect. They all have strengths and weaknesses, and we liken it. The example we talk about is finding needles in haystacks, and you need to mine a number of different data sets to be able to deliver the right coverage, accuracy, and freshness over the footprint that is required.
Hello everyone, and welcome to Problem Solved, a Geoawesome Podcast. I'm Muthu, and I'm joined by my co-host today, Alex.
Hi.
So every episode at Problem Solved, we want to highlight a real-world problem and explore how geospatial technology is solving them, therefore ending with the problem solved. So if you're curious about the real-world impact of geospatial data and tools, you've come to the right place. But before we dive into the session and Jeff and Luca, let's talk about the problem in the first place. So Alex, let's get there first. What is the main issue we're discussing today?
Today we are focusing on a really interesting topic, the convergence of satellite data and mapping data. We'll explore how satellite imagery combined with all the advancements like high resolution, increased revisit rate, or perhaps the growing use of AI plays a key role in keeping this global map data continuously updated and accurate. And today, to better understand how this process works in practice, we've invited two fantastic guests. Jeff from Here Technologies, he will bring deep expertise from the mapping side of things, and Luca from Maxar, who will share insights from the satellite data perspective. Before we dive into details, Luca and Jeff, please take a moment to introduce yourselves to the audience.
Thank you, Alex. Nice to be here. Happy to be sharing this time with you, with Muthu, and with Jeff. I'm Luca Perletta. I work for Maxar Technologies. I've been here for 10 years at Maxar, and today I run the commercial group that focuses on international markets and energy sectors. But during my time at Maxar, I've spent a lot of my time with companies like here, helping them make the most of our data for creating maps and distributing those maps with beautiful imagery to the users. So I'm very happy and excited to be here to share some of my experience in the process.
My name is Jeff Raimo. I've been with Here Technologies about 17 years now in a multitude of roles. I like to tell people I've kind of been from the factory to the customer and everything in between. So product management, product marketing, sales, business planning, business operations, and some other roles. I currently lead a team that coordinates the capture and acquisition of data and the processing of that data to meet our requirements.
Jeff and Luca, thanks for joining us. Between the two of you, it's like you've got decades of experience, and it seems to be like a year full of milestones. We turned 14 this year. Here is celebrating its 40th anniversary. It's an incredible milestone, 40 years of shaping maps. I don't think many companies in the world can claim that. Congratulations, Jeff. I'm sure you and your team are incredibly proud of your contributions to the world of maps. You've certainly made me and Alex very proud of what the mapping industry has achieved. Here, as a company, also has 6,000 patents, ranging from one of the first navigation systems to the latest AI-powered map mapping applications. It's not a mean thing to say you've gone through a lot over the years. I mean, you've evolved from early navigation systems to today's AI-powered mapping. Can you walk us through this evolution and share some of the highlights from your perspective?
It's been an amazing journey if you think about the company, and we have an interesting story how we've started. And it was two guys in San Francisco that saw a problem around people arriving at the airport and not knowing how to get to their destination. So they created a digital map of San Francisco. They created a kiosk. You put a quarter in, you put your address in, and out came a piece of paper with directions to your destination. And that was really the first application of digital mapping and helping guiding somebody from point A to point B. Now that guidance or routing application was obviously the killer app that exploded in the 80s and 90s, and it moved to devices, GPS, obviously into the navigation systems and vehicles. And then we've moved now to advanced driver assistance systems, and over the last 5-6 years, autonomous driving. And if you think about that evolution, when we first started, those first couple of decades, map making was highly manual, and it was humans making maps, and the usage was humans using the maps and interpreting the information on the maps. What's happened over the last 5 to 10 years is a significant shift where now the machines are making the maps, and increasingly the machines are consuming that mapping data. And that's kind of how where we've come from over the last 30, 40 years in this world. So a massive difference.
So let's talk about the role of satellite data in this map making process, and also how it evolved over time. Can you explain this process and this evolution?
Yeah, absolutely. Well, first of all, congratulations to here for this amazing milestone. It's fantastic in opportunities like this to look back and see the journey and how far each company has come and how far we've come together as well. And if I think about our perspective of things, looking back, our first satellite was collecting imagery at 80 centimeter per pixel. And it was collecting around 250,000 square kilometer per day. So that's, to put it in context, is the size of the UK, right? And so back then, from an image, you could see a street for sure. You could see some cars in the street, but probably not a lot more. And if you wanted to map the whole world, that effort in ideal conditions would have probably taken you more than a year and a half to make it happen. And now if you fast forward to where we are today, the quality of the imagery has drastically improved. We went from 80 centimeter down to 30 centimeter native collection, which then we can process with some advanced processing technique to 15 centimeter in high definition. And that is the difference between not only just seeing a street, but seeing lane level information, zebra crossing, bus lanes and parking spaces and so on. But also the quantity of data has significantly increased. Today, our constellation is capable of collecting up to 6 million square kilometers per day. And to put it in context, mapping the world would take us less than a month today. Now, it turns out that that's probably not the best use of our satellite resources. And actually what the users are telling us that they want fresher, almost daily imagery in many places of the world. And that's where we move towards. And so quality is improved, data availability has increased, and therefore fresher imagery is available more often. And last point I'd like to touch on is accuracy. And Jeff mentioned the move towards automatic ADAS systems, so driving assistant features and autonomous driving as well. Well, the first satellites had an accuracy that was in the tens of meters. So when you digitize an object from it, if it is a street or whatever, you could be off like 10, 20, sometimes even 30 meters, right? From where that object is in reality. Today, we are in single digit, and with the right processing technique, we can even go below a meter. And that means that you can actually place objects in the world where they actually are. And if you think about how much autonomous vehicles rely on a very accurate map in order to navigate, it's kind of like, it's clear to understand why satellite imagery is the foundational map, is the foundational data to allow maps like this to exist and be developed today.
I love how the fact we've gone from focusing on technical specifications, the pixels, the revisit times, to what it actually means for the customer. One of the biggest things in the geospatial industry is we tend to focus a lot on what the product can do in terms of features, but not what it means for the customer. So Luca, it's great to hear that you've been listening to the customers and you've been addressing their points. Maybe let's dive a bit deeper into that. From your perspective, I mean, satellite imagery, as you pointed out, has improved tremendously over the last 15 years in terms of spatial resolution, in terms of revisit times. Could you give us more information about what this means for your customers, whether that's here, whether that's other similar customers?
Yeah, thanks for the question, Muthu. The beauty of working with customers like here is that they constantly push us to continue to innovate. And that innovation, I think, from our point of view, you can see it across different places, right? You can see it in the satellite constellation. I mentioned about the 30 centimeter. Probably I should explain better that over the past 12 months, we've launched 6 satellites, part of our WarView Legion constellation, that collect data only at 30 centimeter multiple times a day. And so we have a lot more fresh 30 centimeter high quality data. And therefore, now what we have to innovate on is how do we make that data useful rapidly for our users, for their map makers, for their machines. And so the next step is innovate on the delivery platform. 2 years ago, we started that development with MGP Pro, which is our platform that distribute data. Now, cloud-based platform that allow access to satellite imagery, it's not a novelty. It's been around for many years. But what's changed now is that while in the past, typically map makers would look at the raw imagery, let's say, as they come down from the satellite on a daily basis, now increasingly, they are not just looking at the latest imagery anymore, they're also looking at other type of data set that we can build from our imagery. And the reason why that is important is because, first of all, it's not only just human that look at the imagery, it's also machine. And machine need consistent looking of an image. And the daily image that comes down from the satellite has all sorts of differences, right? There's seasonality, there's atmospheric conditions, there's cloud cover. Wouldn't it be ideal to remove all of those variables and give a machine a standardized image? Well, it turns out that's very, very useful. And so from the delivery platform now, the focus is building the right products to accelerate the map making process and reduce the time it takes to update maps and make them current. And on that front, maybe an interesting example is Mosaic products. In the past, Mosaic products have always been associated with external facing visualization use cases. And so a Mosaic is a stitch of multiple imagery, as you can imagine, and we would normally build that Mosaic once a year. So the moment you build it, then the data start aging immediately, right? Now, to a user that looks at an image as a context, maybe that freshness or lack thereof is not extremely important. But you can't really make maps out of those Mosaic products, or at least you couldn't in a very programmatic way. With the data that is coming down the Legion constellation, now we are able to update our mosaics more frequently, quarterly in fact, and therefore we can give users or machines, whatever that is, a consistent looking data that is also fresh, which is a game changer. And so we have really innovated on our mosaic products. A few years ago, our global mosaic product used to be a 50 centimeter product, updated yearly. Now that's called Vivid Standard and is a 30 centimeter product, updated quarterly. Not only that, but the areas that are more important to our users tend to be urban areas and areas of change, which in the past we used to collect at 30 centimeter. Now we're producing that at aerial quality level, 15 centimeter. Millions of square kilometers of high population density, of high change rate are produced on a quarterly basis, refreshed on a quarterly basis. And so we went from a use of just the latest image that was coming down of the satellite to the use of multiple type of content layers from the users. And so that has triggered a lot of changes and innovation on the way we deliver the data and the way we build the data as well.
So let's translate it now into map products. Right? So me as a user, I get very annoyed if my map or navigation is not updated when I go somewhere and the road is closed or not existing, or I cannot find the address. Right. So now, how does all parameters that Luca just explained translate into here keeping their maps updated all the time?
Yeah, and you're not alone, Alex, as far as getting annoyed when you come across a map error. So if you think about map building, the way I've always explained it, it's at the highest level, it's very simple, right? It's data in, and then it's the processing of that data. And we've referenced AI processing, and we'll go a little bit more into that in a few minutes. But if we focus on the data inputs, they've gotten better and better. And satellite imagery has always been a foundational data input into, I'll call our map making machine. And it's gotten better and better. And as a map maker, you hear three dimensions talked about a lot. It's coverage, accuracy, and freshness. And those are kind of the three main parameters that people use to measure a map. And if you think about the use of satellite imagery, the coverage has gotten broader. The accuracy, as Luca has highlighted, with higher resolution, has gotten better, and then the freshness. So fresher the data, better reflection of reality, then your output is better. So we continue to more increasingly mine that satellite imagery. And again, the theme that we talked about earlier, when we first started using satellite imagery, it was humans looking at that imagery and extracting information from it. Now we're applying algorithms that are extracting detections. And if you go back 20 years, it was literally a line for the road. Now we're extracting lane markings, dividers, other features. Back 20 years, the road could be within meters, tens of meters, and that was okay. Now we need to have centimeter level grade accuracy of these features, and satellite imagery is an enabler for that. So it's really evolved significantly in its the value it delivers, and it works perfectly with the evolution of AI and the ability to extract now all of that additional value that's being created with this higher resolution, fresher, broader coverage imagery.
It still blows my mind that we are more or less never going to be done with mapping. Even in countries where you would expect the map data to be accurate. Just the other day on the road in Luxembourg, the navigation system asked us to take a right where the road was blocked or was not possible. And of course, my cousin turns to me and goes, "You're the map guy, why is it wrong?" And I mean, it should be fixed, right? I mean, maps have existed for a while. So I think I read another study which said, I think users expect a 95% accuracy when it comes to their mapping system. They're okay with it being wrong only a few times. And it's predominantly a service that's not safety critical. We're not talking about life or death situations, but people still have a very high expectation when it comes to mapping. And Jeff, it's been interesting to see how that has evolved from, people looking at satellite imagery in the process, in your workflows, to now AI doing much of the work. But I'm sure it's this engineering input that here has been using has also impacted Maxar in ways that we probably don't know about or discuss. So Luca, can you maybe walk us through how the fact that here is using satellite imagery into their systems, into their engineering framework, has changed how you look at near real-time validated satellite data and your global coverage?
Yeah, absolutely. And we are already talking about it. We're talking about keeping maps fresh. And we have two components, right? We have the satellite in space that can collect imagery where we tell them to. And then we have what the user need, which is really need to know where things are changing so that they can update the map promptly. We've often come across the situation where somebody moves into a new neighborhood and that place has not been indexed yet, right? So you can't get a delivery, whether it's shopping or food or whatever. You maybe are inviting your friends and you have to tell them where you actually are, but the SatNav doesn't know that yet. And so what we are trying to do together with here is making sure that the time from change to map update is as short as possible. And we do that in a number of ways. Of course, we need to have that capacity for fresh imagery. That's by the by, and Legion enables that in ways that it was impossible before. But now it's also understanding where things are changing and anticipating that change, and maybe make our users aware that there are things that are changing that they don't know about yet. Now, of course, here mines a lot of other data as well to figure out where things are evolving. But we have our data from space, and by applying machine learning and AI, we have started to extract changes that are more meaningful to here and to this use case than the generic change detection that is often talked about with respect to satellite imagery. And so within that context, we are just launching now our building and road change product, which is what it says on the tin. Is a change detection, but just tailored to the building, new building, or changes in the built-up environment and roads. And by knowing where those things are changing, we can notify the users about those changes. We can collect the right image, put that image in their hands rapidly, and make sure that that digitization occurs very quickly, so that before you even move into the new neighborhood, that's been already mapped.
Yeah, if I can add a couple of points, as Luca mentioned, no data set is perfect. They all have strengths and weaknesses, and we liken it. The example we talk about is finding needles in haystacks, and you need to mine a number of different data sets to be able to deliver the right coverage, accuracy, and freshness over the footprint that is required. And so what we've increasingly need to do is get these detections from these different data types and then conflate them with each other, because there's still always a certain amount of noise in any data types. And if you want the automation, and the key to freshness is something flowing through the system very quickly, you need multiple validation points to then not have a human get involved. Because now if you have 2, 3, 4 signals that are all saying the same, you can say with a high confidence that is reality, and you can immediately push that update out. And then increasing freshness of satellite imagery is helping us to be able to get more better signals, less noise that match other signals, and with AI push those updates out to our user base faster.
Yeah, I was just going to jump in because one of the things that we like to discuss is the real impact, right? I mean, we've been talking a lot about different numbers, resolutions. At the end of the day, we're talking about how many vehicles use the maps from here, and how Maxar's imagery has improved map freshness and accuracy, and what it means for the end customer. Jeff, do you mind us walking through us?
Yeah. I mean, currently we have more than 220 million vehicles have been sold with her data on board. More than 50 million vehicles rely on our data for ADAS advanced capabilities and autonomous driving. And so, and maybe go back to an earlier point, navigation, the demands on navigation have increased. And to your point earlier, Muthu, around 95%. Well, actually now we're getting pushed for multiple nines of accuracy, even for the navigation use case. Now, if you go into the advanced driver assistance and autonomous driving, safety now comes into play. If you don't get routed to the front door of the destination, it's you're irritated, it's inconvenient, but there's not a safety aspect. Now that the data is used in ADAS applications, where you're advising, you're warning the driver, or you're actually the vehicle's driving itself based on your data, the ramifications of if that data is wrong and the application's reliance on it is obviously much more significant and can be much more detrimental. And so the quality demands as we move into the autonomous driving space are orders of magnitude higher, which is really pushing us to continue to push our suppliers of data, such as Maxar, as Luca has highlighted, and they continue to meet that higher bar amongst our other data types that we leverage, and then internally continue to push our teams internally to continue to use the most cutting edge AI methods to be able to continue to extract this value out of these data sets, and something we call a term we use is data fusion increasingly, because again, data fusion is really the main enabler to be able to drive very high levels of automation, to be able to eliminate the human touch that slows down the update process.
I think that when both of you explain this whole processes and story and data, it all sounds super easy.
Yeah, that's true.
but there must be some sort of a challenge of this mapping story from both perspective of satellite imagery and map making process. So what are some of the biggest challenges that both of your companies still face, and maybe some of the things that we take for granted, we as users, right? But they are constant, continuous challenges that you are working on in the background.
Yeah, I can start and hand it over to Luca. We've kind of touched on a couple of these, and I think the biggest is back to the coverage, quality, accuracy, coverage, freshness, and accuracy requirements. When I started with here 16, 17 years ago, I would have never in my wildest dreams thought that we would be pushed to where we're at and be able to deliver what we're being asked to. And again, whether it's a navigation use case, which is still growing across the globe, right? And markets like Middle East, Africa, Southeast Asia, Latin America. But then obviously in the ADAS and AD space. So I think the continuous raising of that bar is in keeping up with that bar is a huge challenge. Now, the good side is that the technology to process data, the AI, is advancing rapidly, and the amount of data that's available and the quality of that data and the freshness of that data is also growing exponentially, which leads to another challenge of how do you mine this massive amount of location data that is increasing exponentially in a way that you don't bankrupt your company with cloud computing costs is a big challenge. But also, again, it's the opportunity that now exists, because satellite imagery, as an example, today it's not your grandfather's satellite imagery. It's a completely different data set that we can mine and extract so much value now because of the resolution of these features in reality that machines can now pick up, and the freshness of that imagery now. So I'll turn it over to you, Luca, with that.
Yeah, it's an exciting time to figure these things out. And from our point of view, we've always dealt with big data. Satellite imagery are heavy, especially at high resolution. And so many years ago already, we had to push our cloud provider to find new ways to move a lot of data. And some people might recall having a big lorry parked in the backyard of our office, downlinking all the data and then moving them to the cloud physically because of how big the data was. So I think I can relate to that challenge in some ways. But other than that, I think the biggest challenge for us has never really changed, unfortunately. Clouds are the biggest problem, are our enemy number one. And that was true 20 years ago. It's going to be true in the next 20 years still. So for us, the attention is what can we do to minimize the impact of clouds in order to deliver on that freshness that here pushes us to deliver, right? And there's a few things we can do. Some of them have always been important to us. One is making sure that your satellites don't just collect underneath where they're passing. Maybe a little nugget of fact here. 70% of the world is covered by cloud at any given time, 70. And so not collecting those clouds is extremely important to maximize the value of this constellation that you have. So we've always designed our constellation to be agile, to be able to be pointed and tilted towards an area where no clouds are over the area, and maybe take a shot that is more important. Now, that doesn't solve the fact that if where you're passing there is a cloud and you need the image right underneath it, then you still cannot take that image. And so we need to find other ways to solve that challenge. One of the ways we have started to, one of the mitigation that we can throw at it is to place satellites on different orbits, so we have multiple passes at different time of the day. That's what has happened now with WorldView Legion. 4 of the 6 WorldView Legion satellites are placed in a mid-inclination orbit, and so they pass over an area at different times of the day, while historically our satellite would pass in mid-morning, like 10:30 to 11:30. That usually is the best time to take imagery because of the position of the sun and many other factors. But then there's places that at that time they're always cloudy. And so if you can pass earlier in the morning and later in the afternoon, then you have clouds that either have not formed yet, or they've already burnt off, or maybe clouds that have moved. And so if you take multiple shots within the space of a few days, you can still create a cloud-free view that is extremely fresh. So getting around clouds and minimizing the impact of that, it's the number one thing that the team that operates the satellite is thinking about. But increasingly now we want to give the user the awareness and the ability to get the shot that they need when they want. And just a month ago, we launched our WorldView tasking program, which enables user within MGP Pro, either via UI or API, to task directly our satellites. And this is something that our users have been asking us for a long time. And so when here gets multiple signal from different sources that something is changing somewhere and they want a validation, they can immediately trigger an image to be collected as quickly as possible. And very soon we'll be able to give them a forecast of what the weather is going to look like for the next 5 or 10 days, so that they know what likelihood we have to fulfill that shot within 3 days, 5 days, or whatever is their urgency on that image.
To be honest, I never realized that 70% of the time that the Earth is covered by clouds. I mean, when you look at images from the International Space Station, you always see this white haze, but I just assumed that was somehow because of the altitude, but I didn't realize that it's always the case. So that's definitely a huge challenge. And then on the other side, I think big data has always been part of the problem or the opportunity for geospatial. So it's not a huge surprise that here has to navigate through all of these changes. But if you don't, then you don't have those accurate maps that the users demand. So you end up then compromising on what the user needs. So it's a fine line, I guess. So it's quite interesting to see how you navigate through this. I've been playing around with AI for a bit now, generative AI to be more precise. And one of the things that I keep asking is, what is it that Geoawesome is somehow specializing in or focusing in? And it always tends to have a similar answer compared to the other geospatial media organizations, that we love focusing on emerging trends and we love talking about emerging technologies. And that's true. Aleks and I really want to look out for what's next. And we have the opportunity today with 2 companies that we've admired, 2 companies that have shaped the industry, to ask you this question. So what's next? How are you looking at emerging technologies, whether that's AI, whether that's quantum computing, shaping the future of dynamic maps? How do you look at this development? Maybe Luca, do you want to kick things off, because you already pointed a few things about your next generation satellites and clouds being an aspect where you're working a lot on.
Yeah, and it's nice to talk about the future. We started looking at the past, and I think 20 years ago, if they told us what we would have been capable of doing today, we would have not believed it. And so it's interesting to look at the future, because I'm not sure either of us can really say what the next 20 years are going to look like, but I can probably give you a sense of what are the high priority trend for us and where we're focusing a lot of our attention. Of course, our constellation has just been deployed, WorldView Legion, and this is the first constellation that enables us to provide very high frequency, very high resolution imagery. And I think where our interest is now trying to find a way to maximize the value of when we collect those imagery by not necessarily only leveraging our constellation, but also looking at other sources. And we've done some partnership recently, one with Umbra and one with Satellogic. They are other satellite operators. They operate in different spectrum, different resolution, etc. But by working together, today we can orchestrate a virtual constellation that is significantly larger and give us the ability to be more efficient in the way we use each resources. So for example, if you want to understand macro trends and changes, maybe a daily image from Satellogic at 70 centimeter, it's what you need. And then when you find some indicator, something that is happening, then it's when you want to use your 30 centimeter collector to give the best image for the user to digitize off. Cloud is a problem, and therefore going through cloud with a synthetic aperture radar like the one that Umbra has gives us the ability to overcome that challenge in some of the most challenging locations and pick up some changes so that we can notify the users and give better situational awareness of where things are happening. So I think you can expect Maxar to double down on this idea of increasing revisit, but in the most effective way possible, using all sorts of different resources. The other aspect is AI is unlocking the opportunity to really extract information from the satellite in a much more consistent and accurate way than it was 5 or 10 years ago, right? And I've mentioned earlier our building and road change. That's the outcome of a lot of imagery and AI that can be so advanced that can be fine-tuned to a specific use case, to a specific need. And so that move from pixels to insights, it's where a lot of our attention is. And not only insights in general, but insights that are tailored for a specific use case, for a specific market, for a specific problem. And so we're starting on the mapping front. We started with this building and road change, but there's more information that here would want from our imagery in order to accelerate their production. And so that's what we're working on, accelerating the development on.
Yep.
Jeff, looking at you, I guess
yeah.
You've got a lot of things to share as well.
Yeah, I think when I think about the emerging technologies and future of dynamic maps, I think about two different spaces. One is kind of on the supply side, meaning the data and capabilities of here and how that's evolving and what we can do now and in the future that we couldn't before, and then how that can be used. So if I first focus on the front end, some examples of what we're able to do now and will be in the future around supplying end applications with things that were not possible because we're mining literally billions of drives and trillions of detections. We think about a dynamic map in a different way today. Two specific examples is something like traffic signal lane associations. Because we now know drive paths and we know how vehicles behave on those drive paths, and we can map traffic signals and we can group them together and we can associate them with certain lanes, and then increasingly understand if that light's green, yellow, or red, we're able to then power new applications like urban cruise control that understand what lane the vehicle's in and how the vehicle should be operating as it moves through an intersection. That just wasn't possible a number of years ago. Tied to all that drive activity is we now are able to build maps that map the profile of driver activity or driver behavior, which says this is where the majority of drivers, the path they go through. This is how they deaccelerate as they come up to an intersection or accelerate when they leave an intersection. Here's literally where the cars are all stopping at, regardless of where the line is on the road. And that information is very valuable in a number of ways in the autonomous driving space to help our partners understand where vehicles are at and then how they should behave so that they are able to deliver a new natural experience when the cars are driving themselves. On the other side of the coin, on the application side, I think one of the the emerging technologies that you hear a lot of is the software-defined vehicle. And that is a technology that I think is enabling a lot of new things, because if you go back to kind of historically, you would have these different applications segmented in a vehicle, all using different map data. You could have a chip with navigation map data, serving the navigation application, and then another one serving the ADAS applications. As we move to these software-defined vehicles, you can have one map stack that can then serve all of these different applications, which drives a number of benefits, right? So the screen and what the human sees and how the car is behaving match, and there's no discrepancy between those two. Obviously, the cost of the BOM for the car now reduces, because now you're leveraging one database, you're updating only one database instead of trying to do multiple in parallel. So I think the evolution and merging technologies of these software-defined vehicles are enabling new applications that just weren't possible for a variety of reasons. And then our ability to enable them on the supply side with the right data, and increasingly this dynamic data and a dynamic map data that these applications need to do what they're trying to do I think is really, really interesting, very cool, and definitely the future of what we'll all be experiencing in vehicles in the coming years.
It's definitely really cool. And as both of you were speaking, I realized, and I'm sure Alex will agree with me here, we've been blogging, following the space for more than a decade, and I don't remember ever having a period where I said, things seem to become very mainstream and boring. It always seems to be something new, whether that's all the features that you spoke about, optimizing those tiny things like how do you stop at a traffic light, how do you improve the driving experience, or things like, hey, use the constellation from Satellogic to have a 70 centimeter satellite imagery, and then if you believe that there is a significant change that you want to look into, then take the Worldview Legion and at a higher resolution, 15, 30 centimeters. So things are always changing, things are always developing. That's something that I really love and enjoy about our industry. And I have a feeling that we could potentially be talking for the next hour about what are going to be emerging trends and what are going to be emerging problems. But Luca, Jeff, thanks a lot. But before we go, we've got a signature quick-fire question that we're looking at. And I'm going to throw it at you, Jeff, first. What is the one thing you wish the geospatial industry understood better about its customers?
Yeah, I think I'll take that question, spin it slightly, Muthu. So I think, and you alluded to it earlier, is we produce offerings, whether it be satellite imagery, map data, right? And I think you can never lose focus of really that end user experience, whether it's a consumer or whether it's a business application, transportation, logistic, fleet management application, and whatever we're creating in the geospatial community. How is it making those end applications better, or how can our offerings continue to improve so that those end applications work better? And I think sometimes, because we are somewhat map geeks or tech geeks, we are focused on numbers and driving certain things, but those certain things may or may not be important, or be of different relative importance to that end user application. So I think it's just always reinforcing that's all that matters at the end of the day. I mean, nobody really cares about the map, as Alex said. They just care if the road or subdivision is missing and they can't get to their friend's house easily because they're missing the start of the football game. That's what they care about ultimately. But what needs to happen upstream with fresher, more accurate satellite imagery and fresher AI processing of that, and pushing that update out to the end application faster, that makes sure that Alex makes it to his buddy's house in time in that new subdivision to watch that football game. And so just keeping that eye on that end game, I think, is important, and continuing to better understand how everything upstream needs to evolve so that end game is better. I'll turn it over to you, Luca.
Yeah, I think you said it very well, Jeff. And also from our point of view, right? We come from a period of data scarcity, if you wish, even though it was already a lot, to a period of data abundance from space. And so the task at the moment, and what I think it's important for us to recognize, is how do we make that data, which is just data at the end of the day, an information that enables that quick map update, because that's the outcome that we all want to drive. We want to drive a map that is fresh, consistent, and accurate wherever you go. How do we get there? And from our point of view, it's translating that data into insights that are accurate, that are complete, that are relevant, and timely. Most importantly, right? That conversion from pixels to insights specific to the end user need, it's what I think we all need to focus on, and that's what we are focusing on today.
I think that based on our discussion today, I imagine the vision of this self-updating map and I believe that this vision may be happening sooner than we may think. That we'll have satellite imagery that detects a change, tasks high resolution satellites to capture the data. The data is then sent to this map engine that validates it with ground data, also from users, from dashcams and other data sources, updates itself and publishes within minutes to end users. Right? So how soon we are to actually experience that sort of vision? Do you believe it's 5 years, 10 years, or 20 years?
Yeah, that's the vision we have, and we refer to it as the live map. And I think we'll see different aspects of the live map for certain features and certain geographies happening rather quickly, based on the importance of those features being live. But you described it well, Alex. One other quick comment that I didn't touch on: that emerging technology is just moving the detections to the edge. It's like an extension of our map making machine as these edge devices in vehicles or devices are able to not only detect but tell us where there's a mismatch with what we have and what they're sensing, to be able to catch those needles and find those needles even faster. So anyways, sorry I digress, but
we're still looking for a number, Jeff, just to know.
You want a number for the live map. Okay, well, take that as an action item.
All right, guys, it was a pleasure having you. Thank you so much, Jeff and Luca, and thanks to our listeners as well. Don't forget to follow Here Technologies, Maxar, and of course, Geoawesome for more insights. And see you next time on Problem Solved Podcast.
Thank you, everyone.
Thanks, guys.
Thank you.